Okay, this is part 2 of lesson 4D. Here's the homework answers if you need those. Introduction to discrete random variables. Okay, so we're going to talk about expected value, finding the mean and the standard deviation eventually of discrete random variables. So this formula at the bottom there, E of x, that means expected value. It's kind of like f of x, it just means expected value there. Is going to be the amount times the probability plus the respective amount times probability plus respective amount times probability. That is on the formula sheet for sure. It's provided for you. So how would you do that? So let's get this out. Okay, so let's get our calculator out. So we're going to do the amount, which is 0 for that first amount, times 0.001 plus the next amount, which is 1 times 0.006. It takes a second to do this. Plus the next amount, which is 2 times 0.007. We'll just multiply it all together. So plus 3 times 0.008 plus 4 times 0.012 plus 5 times 0.02 plus 6 times. Think of this as kind of a weighted average. That's really what you're finding here. You're finding the average. So expected value is really the average. So that you want to kind of think that way. It just kind of helps. It's the average number. These values aren't equally likely to happen. We'd already talked in class about how 91% of the time you get scores of 7, 8, 9, or 10, or in the healthy range. So it shouldn't be a surprise that the average score, the expected value, the mean score is going to be 8.128. That seems like a pretty common score. 8, 8, and 9 are the two most common scores there. 43%, 31% there. So it should make sense that the average score or the expected value is 8.128 there. So you just, and it's okay to write the little dot, dot, dot there. You don't have to show every single calculation there. It is hard to type that in your calculator. You do have to do that in your calculator, but and the result is if many, many newborns are randomly selected, their average APGAR score will be about 8.128. So again, the expected value is the average. It's really what we're asking when we say that. It's kind of code for that. Let me see what it says there. So yeah, don't report that as an integer. It's a mean. It's an average. Expected value is an average, and it's going to have a decimal to it usually. Okay, so this is the formula for standard deviation. Again, this is on your formula sheet. You would read that as the amount minus the mean squared, so the difference between the amount and the mean squared times the probability. And then you just keep going with that plus the amount minus the mean squared times the next probability, right? So that's how you do that. So is included in the formula sheet, definitely is. You don't usually have to use that formula. What I mean by that is usually we do this, but technology will show you how to do that. I'm just going to show you how to do that. So let's go and type the data into some lists. We'll do this a couple different ways in the lists. So I'm going to call this APGAR, and this one prob for probability. So I'm going to type in 0.001. I'm sorry. So APGAR score is 0, 1, 2, 3, and 10. And we'll type in all those probabilities. So 0.001, 007, that's nice. Okay, hopefully I typed those in right. So we're going to let the calculator do this first. So I'm going to add a calculator page or go back to a calculator page. If you go back to page 1.1, it talks to the other page. So we're going to do regression here. So statistics, stat calculations, linear regression, and APGAR. No, I don't want to do regression. Sorry. Let me do that again. So menu, sorry, stats, stat calculations, one variable stats. That's what we want to do. I was like, wait, we don't need to graph this. Okay, so one variable stats. What's interesting here is you're going to choose one list. It seems weird, but we have two lists, but trust me, it's going to be one list. The X list is going to be the APGAR. And then the frequency list, I don't know how much we've used that. The frequency list will be probability. It's how often that happens. That's the probability of something happening. And so what should happen here, it should give us our mean and standard deviation. Remember X bar is our mean, so it's 8.128. That's the same thing we calculated. And then standard deviation is 1.437. So that's what the standard deviation should be when we calculate this. Usually you're able to just use your calculator like that, do one variable stats, find the standard deviation. That's all you need for the problem. You don't usually have to show the work for that, but we're going to kind of show you how the formula works here. So to remember, if you look at the formula, looking back at the formula, there it is. So the first thing you have to do is find the differences between all of the values and the mean, right? So I'm going to do that here in this column. So I'm going to call this the diff column. And so I'm going to take, in this case, equals. So I'm going to put the formula here. You don't, again, it's just, I want you to understand the concept of what's happening here. See the difference between APGAR minus, I think we found, I need to go back. What was that mean? 8.128. So minus 8.128, which was the mean. So that's going to be the differences column. I'm going to call this one SQ for square. We're going to square the differences. So we're going to take diff squared. Those are all the squared differences. That's the first part. That's the x1 minus the mean squared times probability. So we're going to take this one, I'm just going to call it times. So we're going to do SQ, that column, the squared differences, times the probabilities, times prob. Gives you all those. Okay, so now we have to add up all those and take the square root of the result. Okay, so I'm add up all the times here. So I'm going to say the sum of times, and then take the square root of that number. Let's see if this works. I have my doubts. 1.43. Let's see what the standard deviation was. Was it 1.437? Very good. It actually worked. So it's that process. You could do that. So what they did is, I believe, let's see what they did. They showed their work. They started typing that whole thing in the calculator, which you can also do. They typed that in, basically. So for each value, so the value minus the mean, 8.128, they squared it, they multiplied by the respective probabilities, plus, and they just kept going. And they just typed it all in their calculator. They didn't write it all down because it's just so extensive there, so they put ... and that's okay. And then they got that same number we did, took the square root of 2.066 to get the answer of standard deviation of 1.437. So it says interpret, right? So standard deviation is typical deviation, difference, variation from the mean. So this random variable x, the APGAR score, typically varies from the mean by about mean of 8.125 of about 1.437. Let's see what they said. Oh, if many newborns are randomly selected, the baby's APGAR scores will typically vary from the mean of 8.128 by about 1.437 units. There's no real units to that, so they're just writing that. they're talking about how you could do that thing in the calculator. Oh, we didn't do that. Maybe it might be nice to graph this. Okay, so let's try to graph a histogram in our calculator. So go to Data Statistics, click the APGAR score as your X variable there, and see if we can go to Plot Properties, Add Y Summary List. I think that's the one. If we add Y summary list and we do probabilities, I think it will graph the histogram for us, and you can see how common now those values are, which is kind of nice to see, just a histogram of that. You could also just make one by hand, like we did in class the other day, which is totally fine. So again, they like to see a little bit of work. Sometimes the answers might be in that form, so you have to be able to use that formula if you needed to, just understand it a little bit. But oftentimes you can just do this in your calculator. You don't really have to show a lot of work for this kind of problem typically. Okay, so calculate the expected value for this one. So again, you would just get your calculator out, go to the home screen. So again, it's just going to be the amount, 0 times 0.579, plus the amount times 0.347, plus the amount times 0.069, plus the amount, fortunately this was a little bit less, hopefully I got that right, so 0.956. Yeah, so if many games of Check-a-Luck are played, the average payout will be about 0.956. So what that's saying is, now again, you had to pay $1 to play, so you only expect to get back 95.6 cents. So you're losing 3 or 4% every time you play this game, which is pretty typical of casino games. You're going to be losing something. The odds are not in your favor here, but that's the expected value you expect to get over a long, many games. You have thousands of games. You're getting back about 95.6% of whatever you played when you played the game. Very typical follow-up question, calculate, interpret the standard deviation, right? So if I'm doing this one, what I would do is, go to a listen spreadsheet page. Let's call it Chuck and P-Chuck. P-Chuck is for probability of Chuck or something. So I don't want to use the same probability every time, so you have to call it something else. So 0, 2, 3, 11, and 0.579, 0.347. That's a lot of typing in your calculator, 0.005, right? And then you would go to calculator page and do one variable stats. So menu 611, one list, go Chuck, and then probability of Chuck. Gives you, actually this gave you the mean as well, so 0.956. It also gives you standard deviations, 1.3. You also could have done just by hand, said, okay, I'm going to do square root, if I can remember this, square root of x, which is 0, minus the mean of, oh, I just forgot, 0.956. So 0.956 squared, see if this works, times the probability of 0.579 plus 2 minus the mean, 0.956, quantity squared, times 0.347 plus quantity, we're almost there, we're getting there, so 3 minus the mean of 0.956 squared times the probability of 0.069 plus finally 11 minus 0.956 quantity squared times 0.005. It'll be a miracle if this works. Is that the right answer? 1.3. 1.3. Phew, beautiful. If you do want to graph it, that was not the question, but if you do want to graph it, let's go back to, you would go Chuck, go to plot properties, and number 9 is Y summary list, and choose pchuck, and it does a histogram of that, which is nice. Again, it'll do it for you if you wanted to. And you would need to interpret that number, the 1.3 number. So if many, many games of Chuck-a-Luck were played, the payouts would typically vary from the mean of 0.956 by about $1.303. So that one did have a unit, so it's good to include the units there. That's your lesson for today.